All right, so welcome back to another episode of Studysmart. In this video, we have a complex, although not so complex, but we have a problem under factorial. In our previous video, we talked about a basic introduction of factorial, where I spotted out some vital things in factorial. So in this video, we are going to be taking the factorials of this form and we are going to be solving the problems on them. So the question says simplify, and then if you check very well from the question, we'll have A, B, and C. So we are going to be taking them in bits. We'll take them in bits. So this is A. So let's analyze them. So analysis, we'll take down the first one, which means simplify n factorial over n plus 1 factorial. Right, so this is it. And then we'll be taking this bit by bit for easy clarification. So let's start representing this in factorial. I'm going to be having the n itself, then a reduction in n minus 1 multiplied by n minus 2, then n minus 3 multiplied by down to 2 times 1. Right, so this is what I'm going to have. So that's the factorial of n. N factorial is simply this. You can also extend this depending on the nature of your question. Right, so you can also extend it depending on the nature of your question. You can decide to stop at 1, you can decide to stop here, or you can also decide to stop here. You can also decide to extend it to 4, depending on the nature of your question. All right, so this is for the numerator. So let's go over to the denominator. The denominator will have n plus 1 factorial. Right, so n plus 1 factorial, it means that I will be having n here, this n plus 1, then I'm going to have n and then n minus 1, n minus 2, n minus 3 multiplied by 2 times 1. Right, so that's what I have. So it means that I'm going to be combining the denominator and then the numerator and the denominator, which means that anywhere I see n factorial, I will be representing it with the whole of this. Anywhere I see n plus 1 factorial, I will be representing it with the whole of this. All right, so what it means is that I have n factorial, so this is n factorial over n plus 1 factorial, which is now equal to n factorial is this. And then to make this thing very easier for us, we'll check the denominator first. Look at the denominator, and then the denominator will have n plus 1 factorial. So let's go. We'll have n here, n minus 1, n minus 2, all right, n minus 3 down to 2 times 1, then all over the whole of this. So we have n plus 1, then multiplied by n into n minus 1, n minus 2, n minus 3 multiplied by 2 times 1. Multiplied by 2 times 1. All right, so let's check the numerator and the denominator. There are things that are actually being common. This is n, n minus 1, n minus 1, n minus 2, n minus 2, n minus 3, n minus 3 down to 1. So we are going to cancel them out. This one will go, this one will cancel out this one, this will cancel out this will cancel out this, and then this will cancel out this. So it means that my n factorial over n plus 1 factorial, n factorial over n plus 1 factorial is equal to what is left. So if you check here, nothing is left. So I'm going to be having 1 over. So if you check the denominator, n plus 1 is left. So it means that n plus 1 is left. So it means that my n factorial over n plus 1 factorial is equal to 1 over n plus 1. So that becomes the solution to the first problem. So going over to the second problem. Second problem, which is n plus 1, that's B, n plus 1 factorial over So this is n minus 1 factorial. So this is n minus 1 factorial. So we already know what is n plus 1 factorial from this point. So our n plus 1 factorial is the whole of this. Alright, is the whole of this. And then if you check very well, the denominator here is n minus 1 factorial. And then we have n plus 1 factorial to be the whole of it, meaning that we can also stop here. So what that means is that this is equal to n plus 1 factorial, which is the whole of this, n plus 1 into n minus 1 factorial, because of this factorial, so that we can be able to cancel it out. So this factorial here, this n minus 1 factorial means the continuation of this whole stuff down to 1. So I will have over n minus 1 factorial over n minus 1 factorial. So you check very well, n minus 1 can cancel n minus 1 factorial. N minus 1 factorial can cancel n minus 1 factorial. So I'm left with n into n plus 1. So that becomes the solution to the problem. So, and then lastly, we have this. That's question C. Alright, so question C, we have 2n factorial all over 2n plus 2. Alright, so what that means is that I will be applying this factorial here also. So this is 2 factorial, this is 2n factorial. So 2n plus 2 factorial simply means 2n plus 2. I have 2n plus 1. Then I have 2n factorial. So this is what it means. So meaning that this is 2n factorial and then this is 2n factorial. This and this can also cancel out. So it means that 2n factorial over 2n plus 2 factorial is equal to 1 over 2n plus 2 into 2n plus 1 as our answer. So you see how simple and easy it is. So I just want you to note down some key points in factorial. In factorial, when I have 4 factorial, it means 4 times 3 times 2 times 1. When I have 5 factorial, it means 5 times 4 times 3 times 2 times 1. If I have 100 factorial, it means 100, 99, 98 plus. You are counting down to 1. Right, so cheers. Thank you so much for watching this video. Don't forget to like, subscribe, and then share to your friends. Thank you.